3.3 regular polygons and angles notes. So we're going to review a problem with a hexagon so a hex meaning 6 sides, and you don't have to make a really nice drawing. It's just a rough estimate of what it looks like, and the important things is to label the numbers in. So we're going to have 135 degrees, 110 degrees, 125 degrees down here, 120 degrees, 125 degrees, and x degrees. So the question is, of this hexagon, what is the measure of x, of angle x? And that's the question. So a hexagon, and I can see, has 6 sides. So I'm going to write that down as information. I know 6 sides. And from that, from our work with what we call a math angle sum, I'm going to make triangles. So I'm going to draw in one triangle, and remember, it's helpful to just go from one point rather than crisscrossing, because crisscrossing doesn't work as well, and it gets extra measures. But I have 1, 2, 3, 4 triangles. So I know I have 4 triangles on those 6 sides, and each one of those triangles is 180 degrees. So 180 times 4 would be 0, 32, 720 degrees total. So that's what we're going to be equal to. So when we set up our equation, we're going to equal that 100, or not 180, that is if it was just one triangle, 720, because that's the total we have. So now when we add up all these, that'll be 135 plus 125 plus 120 plus 125 plus 110. And then don't forget your plus x. So I'm going to count them again. So there should be 6 angles. So 1, 2, 3, 4, 5, 6. And that's a good way to just kind of count that you have all of them. Now, how I like to add them up is I like to sometimes add up all the hundreds. So 1, 2, 3, 4, 500. Then I like to add up the tens. So 30 plus 20 is 50, 60, 70, 80, 90, 100. So I'm just going to add 100. Plus, now I'm going to do the fives. 5, or the ones, which are the fives. 5, 10, 15. And sometimes for me, that's a little bit easier to do rather than stacking them all up, which I do also at different times. But these seem to be working well together. So I've got 615. So I'll simplify that more, bring down my plus x, bring down my equals, bring down that 720. So now to solve for x, I just have to cancel out or zero out that 615 by minusing it from both sides. 615. So that would be 2 regroup to 10. So that would be 5. 10 minus 5 is 5. 1 minus 1 is 0. 7 minus 1 is 1. And that is x, bring down the x, bring down the equals, 115 degrees for that total, or for that angle up here that's left over, to make a total of 720. So this helps us remember, or this will help us with our regular polygons. So the word regular, when we go down here, this is a regular triangle. So in our notes, let's put down regular. And regular means all the same measures. And we use the word measures because it can pertain to the side measures, the side lengths, or the angles. So all the angles are the same, and all the sides are the same, and meaning the same number. Or we could use the word congruent. So they are the same when it means regular. So if you ever read that word regular, it is the same. So that means on our triangle, this angle or side length, this side length, and the third side length are all the same measures. It also means that if this side is x, and this side is x, and this side is angle is x, all of those x's are the same, meaning they are all the same measure. So in a triangle, how many degrees in a triangle? Well, there's only one triangle, so there's 180 degrees total. And there are 3 angles, so that would mean that each angle, we just divide it by 3, which would be 60 degrees each. So I like to put that word each, especially when I'm trying to find the measure of each angle. Now, we can't determine what the side lengths are because we're not given any information, but we can figure out that angle measure for each one. So now if we get to a more complicated one, look at this one. So let's take a look at how many angles there are. Well, it's actually hard to count the angles because there's so much going on in these sides. So I'm going to count the sides because the sides are the same as the angles. So I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sides, which means 9 angles also. So I like to sometimes write that 9 sides, 9 angles, or 9 of each. So I've got 9 sides, and now I need to figure out how many degrees there are. So let's do some triangles. So I'm going to pick this one at the top, and I'm going to make a line down this way. There's 1 triangle there. Another one down here, that's 2, 3, 4, 5, 6, and here's our 7th one. So there are 7 triangles, and with those 7 triangles, each one is 180 degrees. So I'm going to multiply that by 180 degrees for each one of those. 7 times 0 is 0. 7 times 8 is 56. 7 times 1 is 7, plus 5 is 1,260 degrees. So now we have to divide that. That's the total degrees in that. So now we have to be careful because we don't want to divide by 7 because that would give us 180 degrees, which wouldn't really make any sense because 180 degrees is a straight line or a triangle measure, and that would just get us back to 7 triangles. So, or 180 for each. What we want to use is that 9 sides or 9 angles that there are. So we take that 1,260 degrees and divide it by 9. Now, some people are like, hey, I need a calculator. Well, we actually really don't, because we can take a look at these numbers and go, hey, 9 is divisible by 3. Is this number up here divisible by 3? And we use our divisibility rule of add the digits. 6 plus 2 plus 1 is 9, and that number is divisible by 3, so they're both divisible by 3. So 3 can go into 9 3 times. 3 can go into 1,200 400 times. 3 can go into the 6, or 60, 20 times. So do we notice how we can simplify our numbers just a little bit more? Some people like to write it over here kind of fresh. I like to kind of do my canceling out up here just to kind of show where I've canceled the 3 out if I forget where I'm at. So I'm noticing 3. Does 3 go into 420? Oh, well, 4 plus 2 is 6. And yeah, it does. So 3 can go into 420 nicely. So 3 can go into, maybe I should do a little bit of long division now. So I get that 3 on the outside and I don't make a mistake. 3 goes into 4 once. 3 times 2 is 3, minus 3, so 4 minus 3 is 1. Bring down the 2, and 3 goes into 12 4 times, and nothing left over, which is great. But remember, we still had this place value right here, so we had to fill that place value in so we get that decimal in the right place. So that means that it is 140 degrees for each angle. Well, each of those 9 angles. Now, if we go down to this one, ooh, another more complicated one. So let's take a look at how many side lengths there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 sides or angles. So that means, remember our triangle rule? There is a rule, there's always 2 less. So if I kind of remember that now, it'd be kind of nice because 12 minus 2 is 10 triangles. Now, if we don't remember that, what we can do is go back and draw those triangles in. And I like to start sometimes at the top and just drag it down. So finding one to each of those corners. And I'm believing these are all straight, even though they look kind of wobbly because I'm just looking at the triangles. So I'm going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So my calculation was right over here. 10 triangles times 180 for each of those. That would be 1,800 degrees total. And sometimes I like to label it total, so it's got a total of that in that polygon. So now I'm going to take that 1,800 and divide by, remember it's the number 12 because that's the number of angles I have. And that's why I like to write it out, give that key information on the page, is because then I don't have to go back and count them again. I can just kind of look where I recorded it. So divide by 12. Now, hey, I know 12 and 18 both are divisible by 6. So 6 goes into 12 twice. 6 goes into 18 3 times. But remember that 18 is in the hundreds place, so it's 300. And half of 300 is 150. And that's why I like to do it here, just a little bit showing less work, but showing the important pieces of the work. Don't forget your degree sign. So 150 degrees each angle. And notice that this one is bigger than the last one because there are more sides or more angles. So our degrees are getting bigger and bigger. So 9 sides had 140 degrees. 12 sides had 150 degrees. What would 20 sides be? That would be a lot more. So we can figure that out also for a regular polygon. Remember, these are regular. Let's put that up on top. Regular polygon or regular 12-sided figure. And that is how we find the degree measure for each of a regular polygon.